In this lesson, we're going to go through several examples of full hypothesis tests, and then we're going to talk about type 1 and type 2 errors. So, in example 1, we have a nutrition company advertises that its protein bars contain an average of 20 grams of protein. A health inspector believes the bars may contain more than what is claimed. She selects a random of 36 bars and finds the mean protein content is 21.2 grams. The population standard deviation is known to be 2.4 grams. We're going to test the claim at the 0.01 significance level. So the first thing we need to do is identify if we're talking about a claim involving a mean or a proportion. In this example, we're talking about the mean protein content of a nutritional bar. So when we set up our hypothesis in step 1, we're going to use mu's. And our null hypothesis is that mu is equal to 20. That's the claimed value. That's what it's thought to be up to this point. And then someone came in and said, no, I think it's more than that. So our alternative hypothesis is mu is greater than 20. Our alpha level is 0.01. And because we're doing a greater than test, it's going to be right-tailed. Now, because we know what the population standard deviation is, that meets the first condition, and we have a sample of over 30 bars that meets the second condition, then we will be using a z-test. So I'm going to come over to GeoGebra, and I'm going to choose z-test for mean. For the null hypothesis, I'm going to put in our claimed value. So mu is equal to 20. The alternative hypothesis, we're doing a test to see if it's greater than 20. So I'm going to choose the center option, the greater than. And then I'm going to put in the information from the sample that was given. So the mean was given of 21.2. The population standard deviation is known to be 2.4. And the sample size is 36. So we have the information now that we need for step 2. Step 2 is to find the p-value and the test statistic. Because we're using the normal distribution, we're using z, not t. Okay, so our test statistic is 3. That's down here, z is equal to 3. And then our p-value is 0.0013. In step 3, we're going to make a decision using the rejection region method. So we first need to find the critical value. Again, because we're talking about the normal distribution, we're going to be using z's. So let's go back to our distribution tab. I'm going to make sure that I'm on the normal distribution. This is standardized, so I'm going to put in 0 and 1 for the standard deviation and the mean. And then because this is a right-tailed test, I'm going to choose the bracket on the right so that everything is going to be shaded to the right. And since our alpha level is 0.01, that's going to give us the area under the curve to help us find our critical value. That's going to be our boundary for the rejection region. So I want to put in that we have an area to the right of 0.01. And you can check to make sure you've got it in the right position by looking at the picture. See, everything is shaded to the right. So our value of z is 2.3263. So 2.3263. That's our z. So that means if our test statistic is to the right of that value, meaning greater than 2.3263, then we're going to say reject the null hypothesis. if our test statistic falls in the blue area to the left, meaning if the test statistic is less than the critical value, so we're going to put in 2.3263 again, then we're going to say do not reject the null hypothesis. So when we look at our test statistic from step 2, our test statistic is 3, which is certainly greater than 2.3263. So we're going to say in this example, for step 3, we're going to say reject the null hypothesis. That's going to be our answer for step 3. Now for step 4, we're going to use the p-value method. So our alpha level is 0.01, so I'm going to put that in there. My p-value is 0.0013. Now when I compare the two, 0.0013 is less than 0.01. So again, since p is less than alpha, we're going to say reject the null hypothesis. So we want to check to make sure we get the same answer for 3 and 4 because we're testing the same thing, we're just using different methods. So in both step 3 and 4, we got reject the null hypothesis. So now we have to just write our conclusion. Since we do reject the null hypothesis, there is enough evidence to support that the alternative hypothesis is true. So we're going to say at the 0.01 level of significance, there is enough evidence to support the claim. And now this is where we put in our alternative hypothesis claim, the claim that we were testing. We were testing that the bars contained more than 20 grams of protein. So here's our conclusion. Okay, let's look at example 2. Example 2 says, a recent survey found that 60% of college students prefer online classes to in-person classes. A researcher believes that the proportion of students who prefer online classes has changed in the last year. To test this, she surveys a random of 200 students and finds that 134 prefer online classes. Given the previous percentage, use a 1% significance level to test if the proportion of students preferring online classes is different than 60%. So the first thing we want to identify, are we testing a claim about a mean or are we testing a claim about a proportion? In this case, we're talking about proportion. So the only test that we have for proportions is a z-test for proportions, but we have to make sure that it meets the standards so that we can use that test. And those standards are, we need to make sure that the sample size times the probability of success is greater than or equal to 5, and n times q is greater than or equal to 5. If I take 200, which is our sample size, and multiply it by 0.60, we're certainly going to get something bigger than 5. And our complement of 60, our probability of failure would be 40%. So if I take 0.4 times 200, we certainly get something bigger than 5. So this shows that we have what we need to be able to use the z-test for proportions. So when I set up my null hypothesis, since we're doing proportions, we're going to use p is equal to, and then we're going to put our claim down of 0.60. And the claim that we're testing, the alternative hypothesis, is that something has changed. It's no longer 60% anymore. So we don't care in this case if it's smaller or bigger. We're just looking to see if it's changed. This is an alpha level of 0.01. Here it gives it as a percent, but as a decimal, it's 0.01. And because we're doing a difference, we're testing to see if it's different, we're doing a two-tailed test. Okay, so in step 2, we need to find the p-value in the test statistic. So we need to go back to hypothesis testing. So I'm going to click on the statistics tab. And we're doing a z-test for a proportion. So I'm going to come down and choose the correct test. Now I'm going to enter all the information. Our null hypothesis is that p is 0.6, 60%. We're doing a two-tailed test. I'm going to choose not equal to. The number of successes is 134 out of a total of 200. So you can see that we have a test statistic. Let me put this in here, of 2.0207, and the p-value is 0.0433. So we have what we need to complete step 3 and 4 now. So in step 3, we're going to make a decision using the rejection region method. So we need to find our critical value. Now, because this is two-tailed, and a lot of people forget to do this, because it's two-tailed, we got to split that alpha level into the two tails. So we got to divide it by 2. So each of these wings is going to have 0.5%, which as a decimal would be 0.005 in each wing. So we're going to go back to our distribution, and we're going to find those boundary points. Where does that cutoff happen for the rejection region? Now we're using the normal distribution to estimate the binomial distribution because the conditions were met. So I'm going to put in normal, make sure I choose normal, and then I have 0 and 1 because we're doing this standardized. And in each wing, I want 0.005. So since we have it on the right wing, I'm going to just put that in now and do the right wing first. So our critical value on the right should be 2.5758. I'm going to put that in. That's right here, 2.5758. That's this value cut off right here. That's the one on the right. Now the one on the left should be exactly the same. It's just going to be negative, but let's double check to make sure. So I'm going to use the left bracket. And then I'm going to put in 0.005. And as you see, I get the same thing. It's just negative because it's on the left side. So I'm going to have negative 2.5758. So if our test statistic falls in the red region, that means we're going to say reject HO. And that happens if our test statistic is less than negative 2.5758. That's this cutoff point. If it's less than this value, then it's going to fall in the red. If the test statistic is greater than 2.5758, then it's going to fall in this area, in the red. So if either one of these is true, we're going to reject the null hypothesis. Now, if the test statistic falls in the blue area outside the rejection region, so that's between the two values. So let me put that in, negative 2.5758, and then over here, positive 0.5758. So if the test statistic falls between these two values in the blue area, we're going to say do not reject the null hypothesis. So when we look at our test statistic, we have 2.0207. That falls in the blue area. That definitely falls between negative 2.5758 and 2.5758. So in this case, we're going to say do not reject HO. So for step 3, that's our decision. Now we need to make sure that we get that for the 4th step as well. So for the 4th step, we're using the p-value method. So we're going to use our p-value, which is 0.0433, and we're going to check it against our alpha level, which is 0.01. 0.0433 is definitely greater than 0.01. So because of that, for step 4, we're also going to have do not reject HO. Now we have to write our conclusion. Since we do not reject HO, we would say there is not sufficient evidence to support the claim of the alternative hypothesis. So I would say at the 0.01 level of, at the 0.01 level of significance, there is not enough evidence to support the claim that the proportion of college students who prefer online classes is different than 60% or 0.60. All right, let's look at the last example for a full hypothesis test. In example 3, it says a Boston sports historian is researching the historical attendance records at the original Boston Garden, which hosted events from 1928 to 1995. Based on archived reports, the official average attendance at major events, such as the Celtics game or boxing matches, was recorded as 15,000 people. The historian believes that the historical figure may be an overestimate due to limited record-keeping methods and frequent crowd restrictions later in the garden's history. To investigate this, she collects attendance figures from a random sample of 16 archived event reports during the garden's final decade of operation. Test whether there is statistical evidence to support the claim that the true average attendance was less than 15,000 people per event. We're going to assume the attendance is approximately normal, and we're going to use a significance level of 0.05. So because she thinks 15,000 is an overestimate, that means she's claiming that she thinks it's less than that. Now, because we are testing a claim about a mean, we're going to use mu when we set up our hypotheses. So for the null hypothesis, we're going to set mu equal to the claimed or the historical value. This is what it's thought to be up until this point. And then someone's going to challenge that and say, no, I think the mean is less than 15,000. So this is the alternative. Because it's a less than test, this is going to be left-tailed, and we're using an alpha of 0.05. Now, because this is a test about a mean, we have it narrowed down to either a z-test or a t-test. However, the population standard deviation is not provided for us in here, so this is probably going to be a t-test, but let's verify that the conditions are met. In order for you to use a t-test, the population standard deviation is unknown, which we know that. But then the second condition is that or statement. Either the attendance is approximately normal, or we have a sample size greater than 30. Now, it says in here her sample is 16, so we have to make sure that we're assuming that it's approximately normal, and that is given down here. So the conditions are met to use a t-test. Now in step 2, I realized that I missed in the context of the problem the information about the sample. So I paused the video and I added that in with this text box, but you should have the correct draft in front of you that has been updated with that information. All right, so to complete step 2, we're going to use the student t-distribution and a t-test, and we need to find the p-value in the test statistic. So we're going to choose t-test for mean. Our mu, our claimed value, is that the average attendance is 15,000. Now we're doing a left-tailed test, so I'm going to make sure that this is highlighted on the less than symbol. And now we got to put in the information about the sample, and it says the sample had a mean attendance of 14,100 and the standard deviation of 920, and we had a sample size of 16. So down here we have our test statistic is negative 4.3478. So let's add that in here. 4.3478. Okay, and our p-value is 0.0003. Okay, now for step 3, we're going to make a decision using the rejection region method. So we need to find our critical value. So we're going to go back to the distribution tab. We're no longer using the normal distribution. For this, we're doing a t-test, so we're using the student t-distribution. So I'm going to choose student. Our degrees of freedom is 1 less than the sample size. So since the sample size is 16, our degrees of freedom is going to be 15. This is a left tail test, so I want to make sure I'm using the left bracket to see everything shaded to the left, which it is. And now I just need to put in my alpha level. The area that should be under the curve from that critical value to the left is equivalent to the alpha level. So we're going to put in 0.05. And our cutoff point, or our boundary for the rejection region, is negative 1.7531. So let's put that in there. So if our test statistic is less than that cutoff point, negative 1.7531, that falls in that red area for the rejection region, then we're going to say reject HO. If it falls outside of that rejection region in the blue area, that's where it's greater than negative 1.7531. So if it's in the blue, then we're going to say do not reject. Now, if we go up and look at our test statistic, we have negative 4.3478. That is definitely less than negative 1.7531. That falls in this red area. So we're going to say reject HO. Now let's do step 4 and make sure we get the same answer. So I'm going to put in my p-value, which is 0.0003, and our alpha level is 0.05. 0.0003 is less than 0.05, so that means we're going to reject HO. So far we're doing good. We see that our answers to step 3 and step 4 match, so we're in good shape. So now let's write our conclusion. Since we are rejecting the null hypothesis, there is enough evidence to support the claim of the alternative hypothesis. So I'm going to say at the 0.05 level of significance, let me make this bigger. There is enough evidence to support the claim that the historical attendance was less than 15,000.